Hello, my dear students. Welcome back to my class. In the series of learning data structures through C, in the previous video, we discussed about the applications of queues, like where actually we use the queue, the field where we can apply the queue data structure. Well, in today's video, we will see how actually this queue is implemented using arrays. That is, the enqueue operation, its algorithm. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So here we have the complete algorithm of enqueue. So let us see how this queue is implemented using arrays, that is static representation. So this is what the array representation, the array name is Q, and let me take the size of n as 5. N size is 5. As usual, you all know the pointers front and rear. Initially, it will be set to -1. Okay. So this is what the memory representation I have written. The array name Q, you can take it as just Q itself, it is left to you. The name is Q, array name, and the index values that what I have mentioned here, it is 0, 1, 2, 3 and 4. So you can just say it is 0, 1, 2, 3 and then 4. Front and rear pointer, we all know the two pointers that what we use for a queue, because in the queue we perform the insertion operation and deletion operation at two different ends. The insertion, so-called enqueue, will be dealt from the rear end, and deletion, so-called the dequeue operation, will be dealt with the front pointer. So we have two pointers, front and rear. Front takes care of deletion, rear takes care of insertion. So two different pointers to perform two different operations. One is insertion, the other one is deletion. Insertion always from the rear end, deletion always from the front end. So we are doing enqueue, means it is insertion. So let us assume that the queue is empty. The queue is empty. No items are filled. And we have also discussed with the values of the queue. Like what will be the value of the queue when it is empty, what will be the value when it is full, what will be the front pointer and rear pointer, which pointer has to be increased, like this. These values we have discussed in the previous video. Please do check out the playlist. Okay. Now, initially we need to check whether the queue is having space or not. We need to check for the overflow. So right now we all know the queue is empty. So we need to check rear pointer. So as we all know, when the rear pointer equals to the queue size -1, then the queue is filled with elements. If it is equal to the queue size -1, then I should say it is overflow. You cannot fill the items. If not, I need to check whether is the item that what I am going to push is the first item, or is it already filled with items? Do we have to simply increase the rear pointer? These things we need to check. So let us check all these criteria one by one. Initially, I need to check is rear pointer equals to n-1. So what is rear pointer? So by default, as I said, the front and rear is set to -1. Now check is rear equal to n-1. So n value that what I have given is 5. 5 minus 1 means 4. Is rear equal to 4? No. Condition not satisfied means I have space in the array to fill the items for queue. So condition not satisfied. Rear value is how much? It is -1. Is -1 equal to 4? No. Condition not satisfied means it is not overflow. The queue can be filled with items. That is the meaning. Okay. Next, condition not satisfied. We'll come to step 2. Okay. Is queue is not filled with elements. If you have space, then is that the first item that what we are filling? That we need to check. Is front equal to -1? Yes, of course. Front equal to -1. Yes, front. By default, as I said, both will be set to -1. Yes, front is equal to -1. Front is equal to -1. Condition is true. Then I need to reset the pointer. So what I need to do, I have to simply reset the pointer. I have to make front and rear pointing to 0. So what I'll do here, I'll make the pointer to point to that. So this is front and this will be rear at the end. But initially what I'll do, at the front equals to -1. Yes, of course, the front means the queue is not filled with items. Initially, we will check whether it is totally filled with items. If not, is the item that what I am going to push, is that the first item or is it already filled with items? So that I need to check now. Is front equal to -1? Yes, of course. By default, front and rear both will be -1. So front equal to -1 condition is true. So I need to reset the pointer both front and rear. What I need to do, I have to reset to 0. So both front and rear will be made to point to the first position, that is 0. Next, else, do we have to execute else? No, because this condition was true. So I reinitialize the front and rear pointer to 0. That is done. Come to step 3. I say Q of rear equal to item. So I just say Q of rear. Rear means it is 0. Equal to, say, new item 10. So I am trying to insert the element from the rear end. I'll come from the rear end. I am storing the first element 10, which should be in Q of rear. Rear means how much? Rear is 0. So Q of 0, I filled the first item. Q of 0 is filled with the first item. Okay. Next, again return back. The next iteration, what I should do, go back, is rear equal to n minus 1. Is rear is pointing to 0. Rear equal to n minus 1 means 4. What is rear? It is 0. Is 0 equal to 4? No. Condition not satisfied. Come to step 2. Is front equal to -1? Again, front equal to -1, I need to check. Is front equal to -1? No. We have already filled with one item. So it is not the first item that what I am inserting. It is the next item. So when I enter from the rear end, in the queue, if already one person is standing, can I go and stand in that particular position? No. I have to go and stand in the next position. That's what I have to do here with aspect to the memory. So here, front equal to -1? No. Condition not satisfied. Come to else part. I need to increase the rear pointer. I need to increase the rear pointer. From the rear end will insert. So I need to increase the rear pointer. So it is rear equal to rear plus 1. So rear equal to rear plus 1. Rear is 0. 0 plus 1 is 1. So rear is equal to 1. Now rear has to point to the next position, that is 1. Now rear is pointing to 1. Then what I should do? I have to come to step 3. Then I should say Q of rear. Q of rear. Rear means 1. Next items I have taken 20. So Q of 1, my next item will be inserted. Right? And again written. Then again check. I need to check with the rear pointer. I need to check with the rear pointer. I say rear equal to n minus 1. So what is rear? Rear equal to n minus 1. N minus 1 means we all know it is 4. What is rear? It is 1. Is 1 equal to 4? No. Condition not satisfied. Come to step 2. Is front equal to -1? That is also not satisfied. Come to the else part. Rear equal to rear plus 1. So rear equal to rear plus 1. Rear is how much? 1. 1 plus 1 means 2. Rear is 2. So now rear is pointing to the next position. So I am incrementing the rear pointer. See here. When the rare pointer gets increased, it is always insertion operation, enqueue operation. So rare is 2. Rare is 2. Then I have to come to step 3. I say queue of rare. What is queue of rare? Queue of rare means 2 equal to, say, next item say 30. So next item I am inserting 30. Again written. Now check, is rare equal to n minus 1, that is 4. What is rare? Rare is 2. Is 2 equal to 4? No. Condition not satisfied. So I have to come to step 2. Again this condition not satisfied. Come to the else part. Front equal to minus 1, because this condition will be executed only at the first time to reset the pointers. Right. Then it will come to else part only, because front equal to minus 1 condition will not be satisfied. I will come to else part. Then I say rare equal to rare plus 1. Rare equal to, rare is 2. 2 plus 1, how much? It is 3. Then come to, so this rare pointer I need to change. Now rare is equal to 3. Rare is equal to 3. Then I say queue of rare. So queue of rare means, what is queue of rare? Rare is 3 equal to, the next item say I am going to push, that is 30. Let me, any items you can just take. So queue of 3 equal to, I just say 40. Then again say written. Then once again I need to check rare equal to n minus 1. What is rare? Now rare is 3. Is rare equal to 4. What is rare? It is 3. Is 3 equal to 4? No. Condition not satisfied. Then again come to step 2, is front equal to minus 1. Again no. Come to else part. Rare equal to rare plus 1. Rare equal to, rare means it is 3. 3 plus 1 means it is 4. So rare becomes 4. So this pointer I need to change now. So it is rare equal to rare plus 1. So it is 4. Now rare is pointing to 4. I have to come to step 3. I say queue of rare. What is queue of rare? Queue of rare means 4. Let me take the next item, say 50. So I am storing the next item 50. Right. Then again go back. What is rare? It is 4. Just remember that. Return. Come to this. Let me write it here. What is rare now? Rare is equal to 4. Is 4 equal to n minus 1 means 4. So this is rare. Rare means it is 4. 4 equal to 4. Yes, now the condition is true. Condition is true. I should get a message. That the queue is totally filled with the values. It is overflow. Then exit. Means done. You just can't do any more next operation. So front will be pointing to 0 itself, and rare will be pointing to the last value, that is 4. So when rare equals to n minus 1, I should get a message. It is overflow. Q is overflow. You cannot fill few more items. So this is what with the Enqueue algorithm. Hope you have understood with this Enqueue algorithm. You have to trace out all these things one by yourself. You have to write down all these things by yourself. Then only you can understand how the rare pointer gets incremented. So started from -1, it was reset to 0, then from 0 to 4. Q size -1. When it reaches Q size -1, then I should say the queue is filled with values. It is overflow. So this is what with the Enqueue algorithm. In the next video, we will see the DQ algorithm and a complete program in the other next video. Right. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.